I'm Alex. I'm the CEO and co-founder of Netris. I just finished part 1 of our network automation, abstraction, and multi-tenancy presentation at Networking Field Day 40. It's a presentation where we share from our experience of deploying and helping many large-scale GPU cluster operators to deploy and automate their networks. And part 2 of this presentation is about lifecycle of the networking. Now, in enterprise data center networking, there was some lifecycle, but here there's a lot more of a lifecycle. It's very nuanced in a sense that there are 2 things. One thing is these networks are very complex, and obviously deploying these networks is more difficult. And there's also this other factor. The way this AI business works, you're never designing one cluster. If your company is sustainable in AI business, your company is going to be deploying more and more GPUs over time. Newer generations of GPUs are being announced, and then your company is buying those. And when you're architecting a system, it's not for one cluster. You're architecting something for long-term long-term strategy. That's why you're going to have a lot of life cycle. And other nuances are these valuable GPUs, when they are shipped to the data center, you cannot play with them for like a month or so till you figure out and you go live. No one will let you do this because they are so valuable that the management of the company you work for, they want these GPUs to go live immediately. The moment the power is enabled, they want to go live and start making money. So this means that your preparation work, your figuring out, your learning should happen early on, before they arrive. And sometimes even your configuration, troubleshooting, and validation should happen before. Now you're probably thinking, Alex, what are you talking about? These switches are not in my data center. How do I validate configurations? That's crazy. It doesn't make sense, right? Unfortunately, this is how it has to be done, and this is what we've been doing with our customers. So we do a lot of simulations. We use simulations, very, very powerful approach. But before simulations, we do modeling, and modeling is it's like source of truth, but sort of next generation of that, because it's slightly more than source of truth. This is and please don't think switch configurations. There's no configurations in modeling. Modeling is information about your topology, what switches you're going to have, what servers you're going to have, how all these cables are going to be connected, some IP addresses. But why I'm saying this is beyond source of truth, because your services, the services that you're going to create, the VXLANs, VRFs, VLANs, and cloud constructs that you're going to create, all these things will be in the modeling. So what happens on day 0, once you order the hardware and the company is waiting for hardware to be shipped and then racked and stacked and powered on, network engineering team is working on the preparation. Oftentimes, it's a collaboration between customer, us, and system integrator or NVIDIA or whoever your GPU vendor is. Oftentimes, it's a collaboration. And what we do during that process, we model the network. We know what is ordered. And how are you going to wire these networks is known in advance. We model that, and we put that into Netris controller running somewhere. And then Netris controller can create a simulation. So think of this. Controller knows what is your master topology, what is it that you are trying to build. But we don't have hardware yet to bring up that network and see whether these BGP sessions come up or not.
Alex, hi, Scott Robon. Is it okay to think of this like Container Lab or other IP-focused virtual-only environments?
This is slightly different. Similar idea, but slightly different in terms of automation, in terms of implementation underneath. So we use two technologies for this. NVIDIA has technology called DSX Air, which is the place where you can, like, through API, you can simulate infrastructures. But we also have built our own. It's called CloudSim. It's not a product. It's used internally. And we initially built it because we needed to be able to test our technology at a really large scale. Before walking into a customer and saying that I can automate your 500,000 link network, like, prove it. So we had to build a technology for us, at least to make our product work in the first place.
I notice you haven't called it a digital twin.
Well, it's commonly called digital twin.
Okay.
Twin-ish.
I'm not trying to lead you anywhere, but okay.
Yeah. Yeah. Sometimes industry calls this a digital twin.
Okay.
So the idea is that you have model in the controller. Once you have physical hardware, controller can program your physical hardware and bring it up. But you don't have physical hardware yet. So you tell the controller, hey, let's create a digital twin using either Netris CloudSim or NVIDIA DSX Air. You put their credentials and your simulated environment comes up. And then maybe network architects and engineers want to, like, look through it, discover some errors. Maybe, or sometimes it's like, oh my gosh, we forgot about our upstreams. Oh, let's redo this part. Or like, oh, how about we integrate our storage here? So this way, all these collaborating teams, all these different vendors are able to collaborate in advance and identify some issues instead of going live and like, oh, geez, we forgot about it. And then with that pre-validated model, you are starting to go live. You're like, now, okay, I know at least my topology, my IP addressing scheme, these basic things are correct. And your hardware is there. Now you need to bring up this, maybe hundreds or maybe thousands of switches. They are powered on, but there's no operating system. So as hardware is, being racked and stacked, someone needs to copy the MAC addresses. Until you open the box, you cannot see the MAC address. When you open the box, it's written on the switch. It's how it works today. In the future, we hope, we're working on this, that when factory ships the switches, we will know the MAC addresses for each switch and its precise location, but it's not there. But it will happen. Today, someone needs to put that MAC address manually, and MAC address is important for the ZTP server to identify the physical box with logical box on the master topology.
Alex, quick question for you. Jason Ginner. As far as topologies, do you have best practices, kind of validated design topologies that are like preloaded into your product, or do you have to build out your topologies by hand? How does that work?
Yes,
both?
We have that.
You have both.
We have both. So there are reference architectures coming from vendors, right? Like NVIDIA has a number of reference architectures attached to like each kind of GPU family. We have some of those, and when we implement actual, customer deployment, sometimes the real deployments are like slightly off compared to like that prescribed reference architecture, and that's fine. They share with us what is it exactly, and we tweak the topology, and because Netris can work with any topology. But what if I haven't ordered it yet, and I don't know what my final topology is gonna be? This is when, like what you just said, we have these pre-built topologies which are basically 100% aligned with NVIDIA's array. Which is like, hey, you don't know what exactly you're gonna do. Hey, take this example array, which is NVIDIA array, build it, launch it, bring up a digital twin, and learn. So this is used for trainings, for demos, for testing things, for two vendors to integrate together. So like, yes, and that's very actively used.
Okay, cool. Another question for you. Do you integrate with a source of truth to pull in like variable data for those topologies, like a netbox or something along those lines?
Yes, there's multiple ways. There's no like magic button between Netris and Netbox.
Okay.
But oftentimes this data is coming from various places. Sometimes we have to work with like an Excel file with like P2P links, and we have a way to like load in Excel file of that. With Netbox, some customers use Netbox, and what they do, they would write few lines of code between two APIs, and then kind of, that code will load something from Netbox and insert into Netris. But inside Netris, you need to have your like Netris specific source of truth, your IPAM, your topology. It has to be in Netris. And some customers absolutely combine that with Netbox, but we do not have that nice, beautiful button.
Okay. Yeah. Thank you.
But it's easy.
Alex, I have a question. Phil Gervasi. Do you also generate simulated traffic, GPU to GPU traffic, so that way you can test failure scenarios, kill a link, take a spine out, change buffer keys, things like that?
Yeah, great question. Yes, it's very limited today. It's like lots of pings like that. But I think there's I don't know if I can share their name, but there's a vendor who specializes in that, basically testing, well-known vendor, and they are working on kind of integration with this kind of simulation technology, so to like simulate more realistic traffic.
So you can do an outright validation that way of performance.
Yeah.
Okay. Yeah. And of course, I think probably primary for a lot of architects is isolating hotspots and failure scenarios more than anything else. So that's interesting.
I'm going to talk about validation in my next slide. So validation, to your point, is big important part. And what you said, that's like some of that exists today, some of that will come later. So how we do today? So when this large network goes up, see, you start with so what you see here, these different colors. So number one is Netris master topology in the beginning. Switches are offline. And you start with that, and switches are starting to get operating system through ZTP, and then Netris agent loads, and it starts configuring, automatically configuring switches, and not only configuring, but also monitoring and validating. So again, there is no such thing as switch configuration in Netris controller. Network engineers do not write configs in our world. They just provide master topologies and they provide policies, but not configs. If you replace a Cumulus switch with Arista switch, you're not going to translate Cumulus config into Arista config. Our algorithm will take care of that, because there was no config to begin with. It was always generated. Now these hundreds or thousands of switches get auto-generated configurations, and because algorithm knows that I just configured BGP on this link and I'm expecting this link to be connected to that link, because algorithm knows what to expect, algorithm is able to do lots of testing. So for example, there's going to be a lot of miswiring, and algorithm will say, hey, this cable was supposed to be connected to port 5, but it's connected to port 6. Please go and swap them. And there's a number of things that, for example, when NVIDIA deploys these clusters, they have like a protocol of things that they test, and we have implementation of all these things. So when NVIDIA implementation team can look into Netris and say, oh, when Netris says it's green, we are sure that network is green, and we can test further the GPU side of things. And that's kind of we work with NVIDIA and the customers. And then comes troubleshooting. With respect to troubleshooting, there are kind of two approaches. Troubleshooting from the perspective of each node. We have agent on each node, and this agent knows what controller knows. So this agent knows like who else this switch is connected to and who are other loopback IPs in this fabric. So at least It can execute some ping. So like these are techniques to troubleshoot things like you cannot misconfigure this network because it is automatically configured. But what can happen, sometimes control planes can break somewhere, or some hardware can be stuck in some weird situation. How you discover things like that? And when you scale your network at a larger scale, you come across things like that more often. Sometimes there's one switch. It looks good, power supplies are there, fans are spinning, ports are up, BGP is up, everything, but something is off. So there's kind of number of tests that we are doing to help network engineers identify kind of weird situations like that. And that part keeps growing. With each release, we keep adding more and more smart tests.